everyone, and welcome to our lesson on square roots and cube roots. When you think about a square root or a cube root of a number, what that means is you're looking for some number such that the product of that number times itself gives you the number that you're looking at. So for instance, you've heard the term square root. If you're looking for the square root of, let's say, 9, you're looking for some number such that that number times itself gives you 9. And that number is 3. So therefore, 3 is going to be the square root of 9 because 2 of those multiplied by each other gives you a 9. If you think in your mind, if anything else could work to make this true, could any other number multiplied by itself give me 9, you will find that negative 3 would also work. Because if you take a negative number times another negative number, you will get a positive number. So taking negative 3 times negative 3, I'll still get positive 9. So actually the square roots of 9 are going to be positive and negative 3. So what are perfect squares? When you hear the term perfect squares, that is going to be those numbers that have perfect integer roots. So for instance, here's just a few examples. 36 is a perfect square because 6 times 6, 2 integers give you 36. 49 is a perfect square given by 7 times 7, so is 100, coming from 10 times 10, and you can probably think of several other examples that are perfect square numbers. So let's practice. What if we need to find the square root of some numbers? 121. So what we're looking for is this situation. Some number times that same number gives me 121. So we'll think back to our times tables and we'll think about some numbers in our mind that could work until we figure out which one truly gives us 121. So we saw in the previous slide 10 times 10 is 100, so we know it's got to be bigger than that. Try 11 times 11. And that one will actually be our answer because that does give us 121. 11, 2 of those, gives us 121, so 11 is the square root of 121. Okay, what about 4? We're looking for some number such that that number times itself gives us 4. And if you guessed 2, you are correct. Now in the previous slide we discussed that the positive and negative version of that number both worked, so we need to remember that 11 would work and also negative 11 for 121, and 2 and negative 2 would also work for 4. Alright, what about 1? This one might be kind of tricky. Some number times itself gives me 1. There's only one number that fits that condition, and that is 1. Also could think about the negative version of that. Negative 1 times negative 1 would also give me a positive 1. Alright, remember we were looking for numbers such that 2 of those numbers gave me the number I was trying to find the root for. That was called square roots. Now we're going to move into talking about cube roots. Cube roots are found the same way, except cube roots, we're going to be looking for 3 of the same number that gives me the number I'm looking for. So we're going to look at an example. Let's say we would like to find the cube root of 8, and that is denoted with a little 3 on the shelf of the root sign. Cube root of 8. So we're looking for this situation right here. Some number times the same number times that same number gives me 8. Can you think of what that would be? Well, if you guessed 2, you are correct. Now let's look at the negative version of that because the negatives also worked with square roots. But let's try it with cube roots. If we take negative 2 times itself 3 times, what would that give us? That would actually give us negative 8, which is not positive 8. So negative 2 is not going to work and is not going to be a cube root of 8. Only the positive version in this case is going to work. Alright, so let's practice finding some cube roots. It may take some trial and error here, before you find the number you're looking for, but just try some things until you get the situation to work. So the cube root of 64, what number times itself 3 times is going to give you 64? You can test some things out in your mind or in your calculator, and you are going to come up with 4. Okay, let's try 125. It's a larger number. I always go back to tens, so 10 times 10 gives me 100. We're looking for the cube root though, so we need 3 of them, so it's probably going to be smaller than that. If you try out some things until it works, you're going to find out that 5 is your answer here. Alright, and here's a different situation down here at the bottom. Let's say you want the cube root of 1 over 27, a fraction. Well, these will work the same way, it's just that they have a top number and a bottom number. So what we're going to do is we're going to do each one separately. To find the cube root of 1 over 27, we're going to find the cube root of 1 and the cube root of 27. So the cube root of 1, what times what gives me 1? There's only one thing that'll work, and that is 1. What about 27? If you try some things here, you're going to find out that the answer to that portion of it is 3. So my cube root of this fraction as a whole is 1 over 3. Alright, you may come across a problem that's requiring you to do this with multiple terms, so let's practice this. So remember how we handled our fraction? We're looking for the square root here, and there's a top and a bottom, so we're looking for some number such that that number times itself gives me the top and the bottom. So I'm looking for the number that is the square root of 16. That's going to be 4. And then on the bottom, the number that is the square root of 4. And that's going to be 2. So the answer to this term here is 4 over 2, which could be reduced to 2. Okay, so let's remember that. So this is actually 2, just a 2. And then over here, I need to know the square root of 81. So what times what gives me 81? And that is 9. So looking at this, simplifying what we can, we actually have 2 minus 2 plus 9. Those 2's are going to cancel each other, and we're going to be left with just 9, the answer to this expression here. And this concludes our lesson on square roots and cube roots.